Hello, my name is Dave Flanagan, also known as Flash, and I head up the secure consulting function within Garrison Technology. Garrison has established a strong and growing presence in the UK, the US and Canada, delivering capability into government, the intelligence community and defence. We have also delivered capability into a range of global commercial organisations, including telecoms and financial services. A key element of this ongoing engagement includes working closely with respective national authorities to assure and authorise new technology in support of new ways of working. It is this that I'm going to be focusing on today. How can we look at new workflows in support of more efficient, effective C2 across the C4ISR space within the broader context of multi-domain operations, MDO? In terms of my background, I've been with Garrison for about 3 years. Prior to this, I spent a little over 20 years in UK defence and national security for a large US systems integrator, delivering deployable ICT and cross-domain gateway services at all levels of classification for the UK Ministry of Defence. I've delivered frontline capability in the maritime arena, including Royal Navy C2 systems, and in the joint land-air arena, supporting UK deployments in OPTELIC in Iraq and OPHERIC in Afghanistan. I've also delivered strategic multinational interoperability services enabled by complex national gateways supporting a range of information exchange requirements for differing communities of interest. This previous experience has given me first-hand knowledge of how the warfighter will adapt and overcome when the system gets in the way. This offers a perspective on how things could change to make their lives easier. My recent experience is providing insight of how organisations like US Army INSCOM are exploiting new technology to enable business workflows that would not have been possible in the past. And this offers a perspective on the technical enablers for change to make the warfighter's life easier. So, framing C2 in a layered environment, shortening the kill chain, and multi-domain operations all need some context. We're all familiar with what multi-screen operations can look like, and many thanks to a previous Tide Sprint presentation for this reminder of overheated rooms, too little knee space, too many keyboards, and the eternal frustration of that bit of data on the other screen. But as you are all aware, multi-domain operations these days means a need to reach much farther than just across classifications. And for the purposes of this presentation, when I talk about shortening the kill chain, I'm referring to minimising or optimising elements of the C2 workflow that get us from data to effect. And I'm thinking of this particularly in the context of the increasing complexity and the increasing risk that is introduced when carrying out multi-domain operations and reaching that much farther. The complexity comes from the vast array of possible data sources. The risk comes from needing to connect and to consume content from those sources. As a constraint on the context, I'm thinking of activity below the threshold of conventional warfare. The reason for the constraint is to head off the conversation around ways of working in a comms-denied environment. I absolutely agree that this is a necessary and relevant aspect for a complete conversation, but I'd like to keep that separate for now. By considering activity below the threshold of an all-out shooting war, then I'm seeking to limit the comms challenge conversation to localised effect and/or the impact of cyber attacks. MDO, and particularly JADC2, has focused some attention on either any sensor, any shooter, or all sources, best shooter. But in both cases, we're back with that reach question to get to those sources. And as well as increasing the number of sources, as I mentioned, we're seeing each of those sources generating a massive increase in the volume and velocity of available data. In its first ever data strategy, published last autumn, the DoD acknowledged that it still lacked the enterprise data management to ensure that trusted, critical data is widely available to or accessible by mission commanders, warfighters, decision makers, and mission partners in a real-time, usable, secure, and linked manner. And as we move towards trying to address these increases, there are equally difficult challenges around ingesting, transforming and getting value out of that data. It's also apparent and was recognised by Lieutenant General Dennis Crawl back in March that trying to standardise all the data as an approach is something of a challenge. In defence, trying to ingest all the data presents several physics and policy challenges. The physics side of the problem includes, but is not limited to, the centre of gravity of the data, especially in the context of an emerging Internet of Battlefield Things across the entire battle space. And by centre of gravity, we're talking about the volume of data and the velocity of the data, how fast it changes. And as you can imagine, large data sets are often not where you need them. The centre of gravity is away from where you want the centre of processing. With that volume, there comes the challenge of volume versus bandwidth. Once I've identified the data set, is it actually possible to move it from where it is to where I need it to be? And anecdotally, it's apparent that volume is definitely winning the volume versus bandwidth battle. Then we have that churn, and associated with the churn is accuracy. How quickly does each data item age out and then become irrelevant? The policy aspect also includes, but is not limited to, the risk of connection being too high to allow your classified system to connect to the necessary sources. So you end up with separate computers on your desk, as we saw in the previous slide. But even if you can connect, then you still can't get at the data because the gateway isn't trusted or simply isn't strong enough to make the data safe to allow it to come across the domain boundary. So, with these problems of physics and policy, what can we learn from the commercial sector, which also has a need to transform data to effect in terms of their business processes, and they have similar physics and policy challenges. Within the context of the physics problems, that conversation generates solution buzzwords like cloud, i.e. it's everywhere, fog and edge computing, how do I change it where it is, and 5G, how do I get at it and more of it. The policy side of the problem is also similar, but in a commercial organisation, that policy around security often gets trumped by business need, and that means taking a lot more risk. And as we're all well aware from the barrage of news stories about breaches, data loss, cyber attacks, etc., it's not an ideal position at the moment. And indeed, as business and security leaders from over 100 global organisations have agreed, the commercial approach to addressing policy and compliance generally is to trust or at least accept the claims of legacy cybersecurity software vendors, throw billions of dollars at complex, multi-layered, secure defences with their mitigations, and then cross their fingers. It's not really an approach that works for government or defence. However, the air gap, and in lots of cases the do without approach, also doesn't work for effective C2. And any of the supporting workflows that we need to drive our ability to overmatch peer and near-peer adversaries. Taking the context that I've now described, and some of the challenges in that context, and recognising the constraints associated with delivering in an MDO, when we talk of leveraging data in multi-domain operations, there are several key dimensions to candidate solutions, to the approaches that we can take. Access, integrity, timeliness, connectivity, and edge are the key dimensions that I'm going to talk about today, but we also need to be cognizant of management, flexibility, the environment, and partnering. So, access. In this particular context, as a solution, you need to be able to reach into your data set. So to address that center of gravity problem, to address the volume, the velocity, and to make use of the data where it resides. From an integrity point of view, we need to be able to address the challenges associated with moving data from its native environment across a domain boundary and sanitizing it and the impact that that would have, and across a domain boundary into different tooling, different internationalization, whatever other factors of that different environment will do to the data and to its original meaning and its original integrity. Associated with both of those is the impact of timeliness. So what happens whilst I wait for the data to be moved, and indeed any latency associated with gateway processing. Both of these factors affect the timeliness between getting data and realizing an effect. The connectivity risk, as I mentioned previously, is associated with how do I connect my high-value system to the vast array of additional resources that are now available in order to make use of multi-domain in the truest sense. And edge is using the techniques from edge computing to deliver processing into the environment where the data resides to extract value in real time. And it is the extracted value that I can then focus on moving, consuming, and supporting decisions on. In terms of those other areas that we're not going to cover off today, management, how do I manage this increasingly complex environment? From a flexibility point of view, how do I deploy and redeploy depending on operational need? Environment, in that context, I'm thinking specifically about what does a solution look like in a strategic HQ compared to a theatre headquarters or operational headquarters compared to a forward deployed headquarters. And from a partnering perspective, how do we address that flexibility in a rapidly evolving partnering environment? As I say, those last four elements will be saved for a later conversation. Today, we're focusing on the access, the integrity, the timeliness, connectivity, and edge, and how they fit into solutions that allow us to get from data to effect most quickly. So that's a quick run through why C2 in an MDO is difficult, and I'm sure there are no surprises there. And I've highlighted some of the specific dimensions to those difficulties. But in terms of solutions, I think it is important to be aware that things have changed. Over the past few years, there has been something of a technology shift that has delivered a range of things. Increasingly powerful artificial intelligence for augmented decision support. Increasingly capable machine learning in deployable packages. Better understanding of edge computing and how to deploy and control ML and AI. More robust cross-domain access technology. More effective cross-domain transfer technology. And enhanced, simplified automation and orchestration. That's software-defined stuff that allows you to bring all of these tools together in a useful, constructive fashion. These and other advances offer a new way of operating with those high-threat networks that could not previously be connected, and of handling toxic, disparate data sets that could not previously be centralized. Many of you will be very familiar with cross-domain access as a way of working in a defined and constrained way. But that means you'll also be very, very familiar with the frustration of not being able to get at much of the content that is necessary to effect truly multi-domain operations. The technology shifts that I've mentioned are now offering new ways of addressing those frustrations in real time across a complex MDO landscape. So I'm going to start with a specific, albeit artificial scenario to describe the changing access possibilities. Consider the tasking, analysis and dissemination workflow for an urgent RFI in the context of an iStar asset. And I'm sure you're very, very familiar with the process cycle, with the way in which those assets are deployed and the way in which they're tasked, controlled, and the product is consumed. In the particular use case I have in mind, I'm thinking of a tactical operator who needs to know what is over the hill. In the context of a model of increased cross-domain access, it is potentially possible that he/she can raise an RFI on their tactical system. Relevant rearward personnel can immediately see that RFI in a window on their sensitive desktop connected to that high threat tactical system, including the relevant multi-liner with coordinate information, etc. By using simple copy and paste to bring that RFI into their high side environment, task the necessary asset in a reliable, effective way, and send it off to look over the hill. The raw data from that asset will then land somewhere within the end-to-end battle space, and depending on which assets are deployed, may land in multiple locations depending on where their ground stations are, how that information is aggregated together. Again, thinking about those data pools landing in particular locations all across the battle space, the relevant personnel can reach into and access each of those data sets to facilitate their processing, their value add, to actually extract the relevant intelligence. And it is that resultant information, that resultant intelligence, can then be published for immediate access by the tactical operator, allowing an effect to be engaged. So just to summarize that, we've got an entire workflow that has facilitated an effect with virtually no need to actually transfer data from the native environment in which it has landed. Stand fast the need to do that initial copy and paste of codes in the RFI for the tasking of the relevant asset. Allowing each stakeholder to reach from their native system, from their trusted high side system and endpoint, into any other system and complete their mission contribution without needing to move the raw data, and keeping the cross-domain transfer element limited to a few lines of text, ensures that high-value personnel can support multiple concurrent operations from a single rearward location, multiple screens, multiple windows on the screens in their desktop. The data is held and processed in its native system using native tooling for maximum integrity. And the information flow is massively reduced and near instantaneous, resulting in an overall massive increase in the timeliness of effect. Enabling all of this through multi-system access from a single pane of glass offers a way to increase operational tempo, to shorten that kill chain, the time delay between accessing data and achieving effect. But from an MDO point of view, this also offers the potential for visibility into a range of other sensor environments that have previously been inaccessible. So, looking back at the dimensions I mentioned earlier, and starting with access, integrity, timeliness, and edge. The essence of access is allowing a user on a classified system to access open source intelligence, for example, the web. Actually being able to reach out to an information resource like the web that is too large and changing too fast to be simply ingested and processed. You can't copy Facebook into your classified system and work on it. The obvious logical extension of being able to browse the web is then actually being able to browse the web and consume a range of tools and data available from such high threat networks. Thinking back to a traditional ops room and that cluttered first picture I shared, one of the key features in that environment is the TV on the wall. And I think, as we all remember anecdotally, historically you'd have the TV on the wall because CNN, AP, BBC were always first on the scene when something happened, hence the TV. These days, that's changed. Imagine an environment where every analyst has TweetDeck or sentiment analysis tools directly on their workstation, directly able to see what's going on in the Twitter feed or Twitter sphere to understand not only what's going on, but what that is meaning for the people who are engaged. How are they addressing and reacting to what's happening around them? That sort of access is incredibly powerful. In terms of the integrity dimension, the hypothesis here is that using high assurance cross-domain access to reach into any remote network system allows the operator to consume the data and information in that remote space using the native toolset in which that data and information was first captured, created, etc. Bear in mind that this covers everything from complex georeferenced multi-layer intelligence down to data published on a web service with a particular internationalization profile, i.e. a particular character set, particular underlying language. Obviously, there are assumptions being made in these cases. For example, the use of a supported VDI technology to allow you to get at those apps, those native applications for generating and managing that data set, or the use of a standard web publishing model to provide a way to actually publish and therefore browse and consume the components. But at this point, we are now talking about the use of open or de facto commercial standards as used broadly across the internet, rather than trying to deal with the complex mapping between differing sets of standards, even with the benefit of the range of STANAGs and ADPs that allow us to move georeference data from one environment to another, but always with that integrity risk. The dimensions of access and integrity and the way in which I describe being able to use a cross-domain access solution to facilitate more easy access to those data mechanisms, to that data information. Together, they underpin the idea of timeliness. By removing the need to move the bulk data around and removing the need to introduce high latency processing and transformation through complex gateways, you end up with an overall increased tempo in terms of operations. You can get at the raw data in its raw environment, distill the important information, make a decision, take an action much faster than waiting for all of that data to be transferred to a central location. So we've talked about access and we've talked about integrity and we've talked about timeliness. Two other dimensions that have come from these emerging new technologies are the ability to achieve higher levels of connectivity with higher threat environments and the flexibility that that then brings to our deployment models and the way in which operations can be stood up. MDO inherently requires reach across boundaries of classification, but also across boundaries of community of interest. So thinking in terms of across defence, across government, non-government and civilian organisations, but also reaching across different levels, strategic, operational and tactical. And then finally, across toxicities, everything from highly classified to the darkest of the dark web. Being able to do this at pace without putting sensitive classified systems at risk needs a connectivity model that is robust enough to be accredited and authorised once, but deployed and instantiated many times. And again, we are seeing new COTS that delivers that robust high assurance connectivity from classified to high threat networks. If we think in terms of the ability to deliver an accredited connection to a cloud environment, then using that as a model for providing a secure way to deliver an accredited connection to any cloud environment offers a much faster way in a much more flexible, fluid partner environment to connect to a range of sources and high threat networks, the data they carry, but most importantly, information that can be extracted from that data in that flexible way in an MDO context. Now, obviously, such a model needs to recognise where the risks actually lie, what risk can be mitigated, and therefore what the residual risk is, and the impact, and how together the residual risk and impact needs to be addressed for any particular instance, rather than the whole end-to-end connection each time. So you have a pattern that has a defined set of risks and mitigations around it. There are clearly articulated residual risks and impacts associated with the specific connection. And because the well understood model has already been assured and accredited and deals with a wide range of mitigated risks, you can focus on the risk per instance for that particular connection. And again, in this particular case, I'm thinking in terms of that access to a cloud service as being an approved thing that you can do. You've managed the risk, therefore allowing you to connect to any cloud service. Think of an NGO, humanitarian ops. Generally, that is a very, very rapid reaction environment where you need to be able to deploy into theatre with your classified system, with effectively a dirty plug on the end of that system that can go into any cloud service in the locale and work with the NGO's local cloud provision, or indeed any of local VDI provision. Any of those mechanisms that they already have in their locale that are already available and already working, but it allows you to plug in, work and access those environments natively in that space. And then when you're finished, disconnect and move on. So, I've talked about how thinking in terms of access rather than transfer can overcome some of the major blockers in terms of enabling MDO. I've done this from the point of view of how new COTS technology can allow classified sensitive systems to connect to high threat networks to access a range of previously inaccessible, high risk, but potentially high value data sources. I've briefly alluded to how this access approach can be augmented by adopting edge computing techniques, underpinned by automation and orchestration tools to deliver the processing engine or engines to wherever the data actually is. And I've also talked about both of these techniques offering vastly increased speed to value, i.e. faster data to effect, that shortening of the generic kill chain. As a penultimate point, I would like to introduce one final aspect of commercial technology that we're all very familiar with, that being the dashboard. In this case, I'm talking about any web-based presentation of key information, and by information I mean the result of processing large or small amounts of data to get something useful, in a way that allows the commander to see a summary of that key information and, if necessary, to drill down into the summary to view the supporting detail. From a decision support point of view, having interactive real-time access to one or more dashboards on a single pane of glass provides a way of disseminating awareness from a broad range of environments without the need to actually transfer data between any of those environments. Dashboarding and web-based presentation is an increasingly important model for allowing decision makers, both governmental, defence and industry, to readily consume key information and can provide a powerful tool for the commander to visualise the status of anything from a civilian supply chain to a complex operational picture. An access paradigm is well suited to exploiting such presentation technology across the wide gamut of systems and networks demanded by operating in a multi-domain environment. And as a final point, I'd like to offer a view that by reducing the dependency on data transfer, it is possible to reduce the degree of binding between systems caused by the need to establish well-defined but inflexible information exchange requirements, to implement the associated data transformation standards, all of which impair the operational flexibility of any given C2 system or system of systems to deploy and redeploy in a complex, ever-changing global environment. The very desire to bring all of the data together may be directly contrary to the desire to increase operational tempo and to ultimately shorten the kill chain in such complex environments. Many thanks for your attention today, and I hope this has proved both interesting and useful. Thank you.